Now we have a basics units converter app that can convert Fahrenheit to Celsius and Celsius to Fahrenheit. But that is really only a minimally useful app. Typical units converter app would contain a whole bunch of different kinds of conversions. So to show how you would handle multiple conversions, and specifically how you would handle remembering what was the last type of conversion that you did, we're going to implement saving and loading settings using the isolated storage settings mechanism. And then we're going to add another menu item on the main page to allow you to select temperature versus teaspoons and tablespoons. And then we're going to add some code to go and read the settings and configure the user experience, configure the labels, depending on what the saved value of the settings was when the app starts. So let's once again come over and open up our Solution Explorer. The first thing we need to do is to add a new class to access the isolated storage for settings. You could do this in code by itself, but it makes it much more convenient if you have a class that does this. That way you can actually implement the saving and loading of your settings as a variable declaration versus having to write a special method for each individual settings with a bunch of code. So let's come to the Units Converter project, right-click, and say Add Class. We'll call it Settings. And in this case, we have a snippet that implements the entire class, so we're just going to select the entire thing. All right, and then we'll expand our snippet. So let's take a look at what this code does. Come back to the top. The only using we need is for system.io.isolated storage. Windows Phone has a separate sandboxed collection of files that are associated uniquely with each app. Means that the section of the file system that's associated with the Units Converter app isn't accessible to the section of the file system in the phone's storage that's associated with the Take a Note app. But it means that you can load and save files in a hierarchy just as you would with any other .NET app. Plus, there's additional facilities that we'll look at when we implement the Sonnets application to allow you to use an on-screen database. But in this particular case, we're going to use a specific part of the isolated storage library that talks about being able to implement settings. First, we declare a class settings of t, so that when we use it to declare variables, we can declare an individual variable, each type for each individual kind of setting that we have. And we keep track of the tag for that setting so that we can use that to talk to the isolated storage APIs and a default value. And you'll see how we use this when we actually implement the settings variable back in our main page.xaml. And then finally, we implement a value property that has a getter and a setter. And the getter says if isolated storage settings.application settings.try get value. So this says, let me go to isolated storage and see if I can find a value for this setting. If I can't find it, we actually set the setting to the default value that you specified in the constructor and return that. If there was a setting that came back, we return the value for that setting. And similarly, when you set the setting in code, as you'll see in a minute from our main page.xaml, we simply call isolated storage settings.application settings using the name of the setting that you passed and store the value in it. So we'll save this and close this. And now we'll come back to our main page.xaml and start using the settings class. First thing we're going to do is to add a using for the namespace for the settings class, because we named that WPET because we reuse the same settings class code in all of the sample applications that we're building. So now that we've done that, we now need to construct a variable that is connected with the settings class that helps us remember whether we're doing a temperature conversion or whether we're doing a teaspoons, tablespoons conversion. So this is how that works. We say settings of type string, and the variable we're going to use to keep track of that is called conversion type. And then we just simply call the constructor for settings with conversion type, which is the tag that's going to be stored in isolated storage, and the word temperature, which is the default value. What happens when this is executed at runtime, when the variable is declared, is that it actually goes, as we saw, out to isolated storage to see if there's an existing value for a conversion type, in which case that's what gets returned versus this default value of temperature. So the first time this code is run, this gets set to temperature. Subsequently, it gets set to whatever value is being stored in isolated storage. All right, now that we're going to be doing multiple kinds of conversions, let's once again select our click handlers, delete them, and now we're going to expand the code snippet and then go look at the code that we pasted in. All right, now let's go take a look at the code we just added. We'll start out here, phone application page loaded. This is a handler that can respond to an event that we're going to add to the XAML that will be called when the page is loaded. What it's going to do is by default set convert value 1 equal to true and call this method called setUpLabels, which is above here, that properly configures the label at the top of the screen, the label at the top of each text box, so that the user knows whether they're converting temperatures or spoons, and whether it's Fahrenheit and Celsius or teaspoons and tablespoons. Now that we've got those two things implemented, and I'll be going over to the XAML in a minute to add the particular attribute to make it call that page loaded handler, we've expanded our convert-click method now to look at the value of the conversion type, because we've got two types now. We've got temperature and spoons. So in the temperature case, we have exactly the same code that we had in the previous version of the app that we had at the end of the last movie. And in the teaspoons and tablespoons section, in that case, we have very, very similar code, except we have two different algorithms here. For teaspoons to tablespoons, you divide by 3. And for tablespoons to teaspoons, you multiply times 3. The two got focus handlers are exactly the same as they were before. And now we have two additional click handlers for the two menu items which we're about to add to the application bar. One to change the settings to say we're converting temperatures, and another to change the settings to say we're converting teaspoons and tablespoons. That's all the C# code we need to do. So let's go to the XAML page and add the 2 bits of XAML that we need to connect these things together. Up here in the phone application page, here's where we're going to add the callout that we want to call our page loaded method. So add that. And so we set the loaded attribute to phone application page underbar loaded. That connects it up to that method in the code behind. And then we come all the way to the bottom. And currently inside of our application bar, all we have is the one application bar icon button. Now we're going to add a couple of application bar icon menu items that are for temperature and for teaspoon, tablespoons, and the appropriate click items here to call the appropriate methods. And now let's run our new version of the app. So by default, just as before, we convert Fahrenheit to Celsius and Celsius to Fahrenheit, but now we have our temperature and teaspoon, tablespoon menu items in the application bar. So we can now select teaspoon, tablespoon, and now you see the name of the page has changed, and the teaspoons and tablespoons text blocks have changed at the top of each of the text boxes. And if we come down here and say, how many teaspoons of oil do we need to make our popcorn? Turns out we need 9 teaspoons or 3 tablespoons.